This is problem 8-111 from section 8.2.3. Show that each of the following equations is true. Show that the left side equals the right side. Alright, so for A, I'm going to write it instead of the quantity squared, I'm going to write it out twice. Alright, so I'm going to multiply. I'm going to do the FOILing method, which is just multiplying without the rectangles. If you like to use the rectangles, go for it. It'll help keep your work nice and organized. So first terms multiplied would give me I squared. Inside's negative 3i, outside's negative 3i, and last would give me a positive 9. So I'm going to combine my like terms first. I just kind of like to do that, and then deal with simplifying the I squareds. So I squared is really worth negative 1. So I'm going to combine my like terms, and I'm going to give 8 minus 6i, which is what we wanted it to equal. Okay. Problem B, if we look at that one, which we have 2i minus 1 times 3i plus 1. Alright, let's multiply that out. I'm going to do the, again, FOILing method. So first terms times each other would be 6i squared. The inside terms would be negative 3i. Outside terms would be 2i. And the last terms would be negative 1. I'm going to combine my like terms. So I have a negative I right here, minus 1. I squared is really worth negative 1, so this becomes negative 6. You're going to multiply the negative 1 times 6. So if I combine my terms again, I have negative 7 minus I, which is what I wanted. Okay. Last problem of C, we have, just make sure you copy it down correctly, 3 minus 2i times 2i plus 3. I don't know what opposites going on. They're not conjugates of each other. Well, wait. Maybe they are. They're just in a different order. Let's see what happens. So I'm going to multiply again, doing the FOILing. So first terms times each other would be 6i. Well, I could do the insides, I guess. I'm not going in alphabetical order of FOIL, but whatever. Then I do the insides next for some reason. So minus 4i squared. Then the outsides would be positive 9. And the last terms would be negative 6i. Excuse me. If I combine my like terms, these actually cancel. Okay, negative 4 times I squared. I squared is really worth negative 1, so this becomes positive 4. So my answer is 13. So yes, they are conjugates. So that remember we said the other day when you multiplied these two numbers together and they gave you a real answer, a real number for the answer, they were conjugates. So these are just kind of in backwards order, and that's what threw me off for a second. So I have basically 3 plus or minus 2i if they were written in the same order, because both 3's are positive and the i's are, one's positive, one's negative. So interesting to notice there. And that was supposed to equal 13? Yes? Yep. Alright, so I could have been able to tell that from the very beginning of the question. Make sure that you're understanding what the i's are. If you need to write down what i's represent, you should notice the pattern with the i's as well. I to the third is going to be negative I, and I to the fourth is just, oops, no, that's a plus I. No. Oh. This would be, yes, negative I, and this would be positive 1. Okay, so if you need to write those down, you can, and once it's larger than this, you should be able to just divide the exponent by 4. If it's a multiple of 4, then it is just worth 1. If it's not, it's basically how many extras do you need to make that happen.